Hi there, welcome to our series on how surface-enhanced Raman spectroscopy, or SIRS for short, can help us fight cancer. Cancer is one of the most feared diseases in the world. It can affect any part of our body and cause a lot of pain and suffering. But what if we could detect cancer sooner, easier, and cheaper than ever before? That would be amazing, right? Well, that's what SIRS can do for us. SIRS is short for Surface-Enhanced Raman Spectroscopy, and it's a super cool technique that can spot cancer cells in minutes without any needles, chemicals, or fancy machines. In this video, we will explain how SIRS works, and in the next video, we will show you how it can be used to detect cancer. So, what is SIRS? It's actually a combination of two concepts: Raman spectroscopy and surface enhancement. Let's start with Raman spectroscopy. It's named after an Indian scientist called C.V. Raman, who discovered it in 1928 and won the Nobel Prize in Physics in 1930 for his discovery. Raman spectroscopy is based on a simple idea. When we shine a light on something, most of the light passes through it, but a very small amount of it bounces back in different directions. This bounced back light is called scattered light, and it can tell us a lot about what the object is made of. Now, most of the scattered light has the same frequency as the original light, and this is called elastic scattering or Rayleigh scattering. But sometimes, about 1 in 100 million times, the scattered light has a different frequency than the original light. This is called inelastic scattering or Raman scattering. Raman scattering happens when the light interacts with the electrons in the object. The electrons can move up and down in different ways, like springs. These ways are called vibrational levels, and they can have different amounts of energy. When a light hits an electron, the electron can absorb some energy from the light and jump to a higher vibrational level. This energy is given by a formula E equals hv that depends on the frequency on the light. Then, the electron can lose some energy and go back to a lower vibrational level. When it does that, it also releases another light. If the electron loses the same amount of energy that it gained from the original light, then the new light has the same frequency as the original light. This is Rayleigh scattering. But if the electron loses more or less energy than it gained from the original light, then the new light has a different frequency than the original light. This is Raman scattering. The frequency of the Raman scattered light depends on how much energy the electron lost or gained when it changed its vibrational level. There are two types of Raman scattered light: Stokes lines and anti-Stokes lines. Stokes lines are when the electron loses more energy than it gained from the original light, so the new light has a lower frequency or a redder color. Anti-Stokes lines are when the electron loses less energy than it gained from the original light, so the new light has a higher frequency or a bluer color. Each molecule produces a unique pattern of spectra, which is like a fingerprint. By analyzing Raman spectra, we can tell what kind of molecules are present and how much of them are there. But there is a problem. The Raman spectra are very weak and hard to detect. Only 1 in 10 million photons of light can produce a Raman signal. That's why scientists have developed a way to enhance the Raman spectra by using metal surfaces. This technique is called Surface-Enhanced Raman Spectroscopy, or SIRS for short. SIRS works by placing the sample on a metal surface that has tiny bumps and holes. These bumps and holes act like antennas that capture and amplify the light. When the light hits the metal surface, it creates waves of electrons that boost the electric field near the surface. This electric field makes the molecules vibrate more strongly and emit more Raman spectra. This is called the electromagnetic enhancement mechanism, and it can increase the Raman signal by up to 1 million times. The metal surface can also change the electronic properties of the molecules by sharing electrons with them, making them more responsive to the light. This is called the chemical enhancement mechanism, and it can increase the Raman signal by up to 100 times. The chemical enhancement mechanism only affects the molecules that are directly attached to the metal surface, while the electromagnetic enhancement mechanism affects all the molecules near the surface. SIRS is a powerful technique that can detect even single molecules in very low concentrations. It has many applications in different fields, such as biology, medicine, archaeology, forensics, and pharmacy. For example, SIRS can be used to detect proteins and biomarkers that indicate diseases such as cancer. It can also be used to analyze ancient artifacts, identify drugs and explosives, and monitor chemical reactions. I hope this video has helped you understand the principle of SIRS better. In the next video, we will talk about how SIRS can be used to detect cancer cells. Thank you for watching, and if you want to learn more about SIRS, don't forget to subscribe to our channel.